This is my presentation on G7 color calibration. My name is Carlos Gonzalez, and this is based on a report by me and my group. G7 color calibration is a system that was created and approved by the industry. It was created to help with inconsistencies that occurred within print products. And because of G7, the industry had a lot more success in print in its products because it created a safe and reliable way for files to be transferred between servers. This safe and reliable way allowed for print products to have a similar color palette or a identical color palette to the original file. This often worked off of the equal amounts of cyan, magenta, and yellow, which is CMY, to create something called a neutral midtone gray. This neutral midtone gray is how other print systems identify or calibrate to its color. The purpose of G7 color calibration, it was created by the International Organization for Standardization, which is ISO, and it was essentially a set parameter or they created print targets for the standard of, quote, good printing. SAPI, which is one of our articles, stated that the goal was to develop a system which allowed for common files to be routinely shared between printers. This was the main problem, which was why G7 calibration was created, and it was because of the inconsistencies mentioned earlier. This is the problem that the system needed to fix, because before there was only dot gain, which was not an industry-approved system to begin with. These were some of the articles that we used on our report. Sinazon went into depth on how G7 calibration works and what came before it. It explained how systems used dot gain or tonal values to create neutral grays, but they always came off color or with plenty of inconsistencies. SAPI, another one of our articles, explained the G7 background and how the industry did not have a set approved standard for print, which is why results came out with several flaws. It explained that G7 calibration was created to solve these problems, to solve the problems of transfers between files and the problems with color modes not correlating. Graphics engineering or graphics industry explained the levels of G7, where the first level or the fundamental level is, quote, defined when printing systems are able to reproduce true neutral gray using unequal amounts. The secondary level is when G7 grayscale levels are matched and the colors between these printing system G7 standards are in line. These were just some of the articles that we used for the report to better explain what G7 calibration was. The four main functions of G7 calibrating are a visual grayscale, calibrating a proofing system, controlling the press to maintain the grayscale throughout, and also controlling the proofer for the same grayscale. This is essentially how G7 calibration works. It works throughout the entire printing system, and it makes sure that every portion of the print matches its color to begin with, so that whatever file comes in matches the colors of the file that comes out. Lastly, G7 will continue to be a leading industry standard system for all forms of print. It will continue to be a growing calibration system because it has spearheaded the graphics and printing industry in ways that we couldn't imagine. G7 color calibration has become such an industry standard that many forms of print are now relying on it for their color calibration because its ability to create a true neutral tone gray and match the colors of the end print product and the beginning transfer file are outstanding.